let us discuss pin diagram and memory organization of 8085 microprocessor. Pin diagram of 8085. It is an 40 pin IC, so starts from 1 to 40. It has been classified into 7 groups. Let us see one by one. The first one is with respect to address and data lines. Since it is an 8-bit microprocessor, it has D0 to D7, total of 8 lines. And to address this, we have A0 to A15. Lower order address is multiplexed with data lines that we can see from the diagram, that is pin 12, 13, 14, 15, 16, 17, 18 and 19 are used for both address and data lines. Initially address will be transferred from your lower order address and then higher order address. Then by using ALE, address latch enable, initially we will keep it as address lines. Once the address is been passed, then with the help of that ALE we will make the line to be data line. In 8085, that is from pin 12 to pin 19 and pin number 34 are for two purpose, whereas nowadays latest microprocessor are all lines will have more than 2 operations. The second group is, we call it as control lines. Word itself, it is very clear. It is going to control whether data is from microprocessor to the external or to the external, from the external to the microprocessor, that is read or write. These two are marked with a line above, that is, these are active low signals, which will be activated only for logic 0. The RD bar, the signal indicates that selected, whether it is input, output or memory, is going to be read. And WR bar is for whether it is going to be written in the selected memory or the input output device. To do this read and write, we should have help with ALE, that is address latch enable. It is a positive going pulse generated when a new operation is started by microprocessor, that is the address bar data lines has to be an address line. So when this ALE is 1, that address bar data line will be given as an address. When ALE is brought to 0, automatically the address lines will behave like data lines. Then the third group is your status signal, that is these two lines, that is line number 33, line number 34 and line number 29. So when you see this status, the first one is IO bar M, where again above M you will have a bar which is indicating if this line is 0, then it is showing that, or it is stating that now the transfer is between memory and the processor. If it is 1, this indicates it is going to be with respect to input output. There is no specific application of S0 and S1 in case of microprocessor, whereas It has been well used in latest microprocessors. The next group of lines are power supply. For any microprocessor or microcontroller, for the operation, you should give power to the processor. It is like giving food to human. So 5 volt supply is required for 8085, and now latest microprocessor and microcontroller require lesser voltage compared to your microprocessor which was developed in 1970s or 80. Next group is clock pulse. This is like a brain. You have given food to human, food is went inside, now there should be a pulse. If this pulse is missing, then it is dead. In some case, person will be live but he cannot do anything, that is coma. So similarly here, only power supply is not sufficient, clock. So there is 2 pin X1 and X2 across which you have to connect your clock or crystal. Nowadays we use crystal, initially it was RC combination and all. This used to set the frequency of operation. Generally 8085 microprocessor we use 6 MHz, which is internally divided by 2. So operating frequency is 3 MHz. The next pin is clock out. See this, you can see it clear. Here it is clock out, a pin is there, and there is 2 pin across which you have to connect crystal, which is pin number 1 and pin number 2. We connect high frequency crystals. That is what I told you will connect a 6 MHz. See nowadays, latest processor are working in gigahertz speed, whereas this one will work in only in megahertz. You will connect 6 MHz crystal, which is internally divided by 2 and operating is 3 MHz. Now we see what is need for that person called clock out. Clock out is, this signal is used as a system clock for the device connected to the microprocessor. We will connect n number of device like memory, where it has to synchronize with microprocessor, or in other words what we say, microprocessor will be the master and the remaining are slaves. Slave has to work as per the instruction from the master. So brain should be from microprocessor. So microprocessor will generate the required pulse to that slaves to work properly. Next set of groups are called as interrupts and externally initiated signals. Interrupts are externally initiated signals. We will be working in a sequence, and based upon the input the program has to be executed. In that case, suddenly an interrupt will occur and try to stop, and the task will be continued, and then after completing it again the program will start executing. So interrupts are the signal generated by the external device to request the microprocessor to perform a particular task. In 8085 there are 5 interrupt signals, that is trap, 1.5, 6.5, 5.5 and INTR, where highest priority is trap. If simultaneously all these interrupts occur, then the first person that should be executed is trap, next 7.5, 6.5, 5.5 and lastly is INTR. We will discuss deeply when we see interrupts separately. Then INTA, it is an interrupt acknowledgement signal, that is microprocessor is saying okay, I will stop and I will continue with your work. So it is giving an acknowledgement that interrupt is being accepted. Then reset in and reset out. Reset in, resetting inside. This signal is used to reset microprocessor by setting program counter to the 0. As we discussed earlier, the program counter is nothing but which is tell the next line where next line to be executed. So if it is executing 4000, program counter will say 4001. So after executing program line number 4000, you have to go for 4001. That is the work of program counter. When you reset in is been done, microprocessor will be resetted. It will go to the starting address 000, 4 zeros. Reset out. Reset in is for resetting its own self. Reset out is for resetting the external device which is connected to microprocessor. So signal used to reset all connected device when microprocessor is reset. So when you see here, there is a reset in and another one is reset out. So it is very clear, this when you press this particular, it is input to the microprocessor. So we will connect a switch to this particular line, and again this is reset in is active low. So this will be done only if this line is brought to 0. Why we should have some lines to be with the bar, which is that it is more cautious. So in room or the environment in which you are using, there will be noise. So noise is like in digital it is active high. So any such pins we should not react to the environment, we will keep it as active low pins. So that is why this pin is kept in active low. So under noise condition this will not be triggered. This will be triggered only if you want. So we will connect a switch to this and we will bring it to 0 so that this will be reset and the entire processor will get reset. Once the processor is reset, its subordinate also should be resetted. So it will send a signal out which is called reset out. So arrow is clearly pointed, it is for out, and this is in, you have to do. So that is with respect to interrupt. Then it is ready. This signal initiate that the device is ready to send or receive data. If ready is low, then CPU has to wait for ready to go high. So once it goes high, then automatically it will send or receive old. This signal initiate that another master is requesting the use of address and data bus. Old is temporarily I am not using the memory. Sorry. So it is some other person is going to use. Old acknowledge. When you request for old, then I have to give acknowledgement. Again, you can understand it by the way the arrow has been shown. Old is from external to say that if I put you in old, which means you are not going to use your memory via address lines. So your memory interfacing will be temporarily stopped. And if I acknowledge, then only I am accepting what you are giving for old. Then next set of group is serial input output signal. There is two way of communication, one is parallel, another one serial. Parallel is very fast. So in closely connected device we go for parallel communication, so it will be very fast. Disadvantages, if the distance increases, number of lines increases. So that is actually speaking, we cannot put a very lengthy line, not so many number of lines. See, 8-bit means you have to put 8 lines, so that is not possible. So we go for serial communication, whereas here only 2 lines is used. One is SOD, another one is SID. Serial out data line, serial input data lines. Data on this line is located into accumulator whenever RIM instruction is executed. Read, interrupt, mask. So these 2 lines are there here. So we can see pin number 4 and pin number 5. So with this we have come across all the pins in your 8085. All this 40 pins we have seen. And next part of the today's session is memory. So memory, we have 2 types. One is read only memory and then random access memory. In read-only memory, the data is permanently stored in the memory and the device are masked programmed during manufacture. That is, once the device has been manufactured, they will write the program and that particular pin, right pin, will be broken or it will be masked. Then further you cannot make that pin to go to low and you can do the write. Say I have already told there is a pin called write and read. When you want to write, you have to bring it to active low to that particular pin, then you can write. So what they will do in ROM, they will mask it such that you cannot go and touch that pin at all. Cannot be reprogrammed and are of non-volatile. Volatile is whenever supply has been taken, everything will be erased. That we call it as volatile. And read only memory are non-volatile. So they are permanent. What is being written is permanently written. These devices are cheaper than programmable memory device. There are 3 subdivisions. Application, we all know. When you want to compare anything, you have to have some data that we will call it as lookup table. Then for conversions, like you get a particular value, multiply with some particular value, you get an output. So to multiply this, you should have some equations that should be written. For an example, when you have in terms of speed in terms of omega, and when you want to convert it into RPM, then you do some multiplication like 9.54, and that is called as written as you will have. So you will get the data, multiply and do all these things and do the conversion and get the output. So that part of the program has been written. So that is the application of read-only memory. There are 3 types. First one is programmable read-only memory, then erasable programmable read-only memory, and third one is electrically erasable programmable read-only memory. Then in RAM, we go on to the next type, that is random access memory. So in random access memory, there are 2 types. One is static, another one is dynamic. Under static, stored data will not be changed with time. So once you store it, is stored there. I will not go and change it. Whereas in dynamic RAM, stored data will be changed with respect to time. Since this does not change, static RAM, constantly power is being used, so consume more power. Less consumption is less when compared to static in case of dynamic. Then when you want to store it continuously, there is it is expensive, whereas dynamic is less expensive. High packing density for dynamic RAM, which means more content can be stored in less space, are not easy to construct in case of static, whereas dynamic is easy to construct. No refreshing is required because you constantly you store the same thing, so no need for refreshing in case of static, whereas that is required in case of dynamic. And since no refreshing, no maintenance, since continuously refreshing, you should have maintenance. Then we will compare the 2 type, read only and random access. Comparison chart says about erasing property, then writing mechanism, then volatility. Then so read only memories are non-volatile, so they will not get erased, whereas your random access memory are available with volatile and non-volatile. Then erasing is first case, it is not at all possible. Only in erasable, that is EEPROM, there will be an opening on the top. You have to give ultraviolet light, then automatically whatever and all is written will be erased. Then again you can write electrically. In electrically erasable EEPROM, there you don't have any opening on the top, rather you will have a pin. That pin, if you bring it to 0, you can erase what and all content will be there, will be erased, and you can write. This is for random access. In case of random access, you can electrically, whenever you want, you can write and rewrite. Then we move on to organization of memory. So address lines from your microprocessor should be connected to the memory, and the output lines should be connected to your data lines. So from your address lines you will have decoder is for, see, you have 4 lines, you can make it as 8 lines or 12 lines by using a proper decoder. This decoder will be have chip select, that has to be selected from the microprocessor so as to select this. Once if you select this and then you have give your address lines, you can generate the required number of address lines, and that is being connected to your memory, and your memory output lines will be connected to your data lines. We will see it clear. So this is how it is being done. Now we will see what is called latch. Latch, from the word itself, it is like putting latch in the door. So a single room having 2 doors. When you open one door, then the lines are address lines. Close that door, open the next door, then it will become data lines. So if it is 1, ALE is 1, then it will behave like an address line, and if ALE is brought to 0, this line will become data lines. So initially it will be address lines when this fellow is 1. When this fellow is been brought to 0, this address lines will no more, this gate will be open, so this gate will be closed. When this gate is closed, nothing will be out from this side. So whatever now the lines giving is data. So we will see the schematic block diagram of memory as well as input output interface with microprocessor. So this is memory, this is input output device. Usually memory can have 0 to 16 address lines, whereas input output device you can have 8 lines. Okay, control bus is to say whether you are going to write or going to read. So both can be done. You can memory read, you can do memory write, you can do. Similarly, input output read and input output write you can do. So this is a comparison between memory mapped input output and memory mapped input output. So I told that when you go for memory you use 16-bit address lines, whereas here it is only 8-bit. So MEMR, memory mapped memory read and memory mapped memory write, both are active low. I have already told which required control we usually keep active low so that external noise doesn't disturb. So this is an example of connecting an 8K 8-bit memory. So this 8K is indicating it is 8K and this 8 indicates it is an 8-bit. Okay, now you should know for how much connecting an 8K, what is the required number of lines. It is so easy, 2 to the power. So 2 to the power 12 will give you a value. So let us calculate what is 2 to the power. So when you calculate 2 to the power 12, then if you divide it by 1024, it tells the size of your memory. So that tells it is in 8K. So that lines is being used, and these 3 lines are left free, which is used for selecting the chip. That we here I have shown only one 8K. You can connect 2 or 3, 4, 8K, 3. You can connect 3 8Ks where you use single address lines for particular selection of that particular memory. So if 13 is alone is given here, once this 13 is 1, which indicates this particular 8K RAM has been communicated. Okay, so you have, that is with respect to this address lines. Then control, since I have told is memory, you will have read and write. Now this diagram is specifically saying that it is interfacing input output memory read and memory write. I am not going with input output. So input output I am not going, I am going with memory. So that is why it is there bar. So it becomes memory read and this is memory write. So with this we will wind up with the second topic in microprocessor and microcontroller. Thank you.